Good morning. I'm Yeo-Ra Chae from Korea Environmental Institute. First of all, I'd like to thank British Embassy and British Trade and Cultural Office and CIER for organizing this event. We are very happy to have an opportunity to present our studies, and I hope this event is a starting point to sharing our knowledge and experience between two countries. Yeah, you heard about two presentations today. One is about the scenarios, and the other one is about the climate change mitigation. And I'm going to talk more about the whole story of the project. This is the economic analysis of climate change in Korea. This study has been done about 2 years, and the PI, the principal investigator of the project, is Dr. Hwae Seong-ri, who is the vice chairman of the IPCC. And about 20 researchers has been participated in this project. Climate change affects many countries in the world, and Korea is no exception. So temperature rise in Korea is about 1.8 degrees, and compared to global average increase, it's 0.8% for last 100 years. And we also experienced the frequent occurrence of extreme weather, which include heat wave, heavy rain, heavy snow, and everything. And although we experience lesser number of typhoon, but the intensity of the typhoon is getting higher. And we also experienced the higher rate of sea level rise in Jeju Island, which is approximately 3 times higher than global average. So temperature rise, the precipitation increase, sea level rise, extreme weather, and typhoon. So there are a lot of climate change impact affect Korea. Oops, sorry. So we have to do something about this. So how do we deal with climate change? That is the objective of this study. So the objective of study is conducting a comprehensive assessment of physical impact and economic cost of each climate change impact categories. And we also assess the GHG mitigation cost presented by Dr. Kim earlier. And we also estimate the economic impact of climate change adaptation policies. So by doing so, we hope to present the national level counter strategies based on our integrated economic analysis of climate change. The special range of this study is South Korea. Then we have the base year as 2008. And we estimated the impacts until 2100. The main study area is climate change and socio-economic scenarios of Korea. And we estimate the climate change vulnerabilities and economic analysis on 5 sectors, which is water resource, forest and ecosystem, food resource, human health, and coastal area. And we also estimate the cost and effect of GHG mitigation. And finally, by combining all this information, we did the integrated cost-benefit analysis of climate change policy in Korea. Climate change affects many categories and many sectors. And this table summarizes what possible or potential categories affected by Korea. The water resource, forest ecosystem, coastal area, food, infrastructure, human health, and many things else. And there are many subcategories. And the columns marked by circle are the area analyzed in this study. And there are a couple of studies analyze the economic impact of climate change, both in global and national levels. The Stern review analyzed the global level, and some studies like Garner report analyzed economic impact in Australia, and NRDC about the USA, and ADB studies about Southeast Asia. And each studies analyze different sectors. That is depending on their national or regional circumstance or research capabilities. And we analyzed these sectors. And this figure shows the structure of this study. So, as presented by Dr. Lim Dong-sun, we developed scenarios for climate and social economic indicators like economic growth rate, industrial structure change, land use change, and population change, and energy consumption and GHG emissions. And this assumption applied for both bottom-up study, top-down study, and GHG mitigation cost. For bottom-up economic analysis, we analyzed the economic impact for economic sector and non-economic impact. For economic impact, we analyzed the impact of water resource, agriculture, and coastal area. For non-economic impact, we analyzed the impact in human health and ecosystem. And by combining this bottom-up study and GHG mitigation cost, we did the integrated analysis of the climate change impact in Korea using the page 09 model, which I explained later, more detail. The scenarios, but yeah, which is already explained, so I'll skip this. And first, the impact we analyzed in the water resource. For physical impact of water resource, we analyzed impacts for rainfall and runoff change in 4 major rivers in Korea. And we find that the rainfall, the annual overall average rainfall change is expected increase until year 2100 compared to year 2009. In 2008, you can see that, but we find that there is a decrease in rainfall between year 2013 and 2060 period. So we have to prepare this possible shortage on this period. And we also find that the seasonal distribution of runoff is expected to vary. So it's a little bit harder to see, but we find that summer seasonal runoff is also expected to decrease. So when we need more water, we might have water shortage for the summer season. So economic impact of the water resource is we find 107 billion Korean won in year 2100. And second sector is forest and ecosystem. For physical impact, we estimated climate change damage for distributional change, function, and disaster. For distribution, we find that compared to the past, the far-into future, the subalpine zone and cool temperature zone will decrease about 25%, and warm temperature zone and subtropical forestry will increase about 65%. For functional change, we find primary production and potential soil carbon stock will decrease. And for disaster, forest fire and the landslide has become more vulnerable in Korea. And we also did the economic analysis of this impact in forest and ecosystem. And we find that in the economic damage of forest ecosystem due to climate change is about 293 billion Korean won in year 2100. For food resource, we analyzed the physical impact of potential production change of rice and barley. And we find that the rice will be decreased in production until 2100, and barley will increase in production in year 2100. And we estimated the economic impact of a food resource sector with and without adaptation. So if there is no adaptation policy, the continuous increase of annual growth by climate change impact is expected. However, with adaptation, we expect the increase of annual profit in agriculture sector due to climate change impact compared to no climate change impact. For human health sector, we analyzed the damage by climate change on the extreme heat wave, and we estimated the extra premature mortality due to heat wave. And we find that in year 2100, about 8,715 people will die because of the heat wave. However, with adaptation measure, such as the alarming system, heat alarm, the number of excess deaths will decrease by 1,251. And economic impact of climate change damage in human health sector is about 1.4 trillion Korean won in year 2100. And with adaptation, the damage cost will decrease about 206 Korean billion won. For coastal area, we analyze the impact both by flood and erosion. And we find the flood, the area of flooded west surface will be about 2,000 square kilometers, and dry area will be 240 square meters, and about 150,000 people will be flooded and home loss. And for erosion, the average rate of erosion is about 40%, and the west coast is more vulnerable to erosion due to sea level rise, which is about 50%, and compared to east coast is 27%. And the economic impact of this climate change damage in coastal area is about 7 trillion Korean won in year 2100. So we expect very high climate change damage in coastal area. So we did this kind of analysis in 3 years, 3 snapshots, about 2020, 2050, and 2100. So depending on scenario, so what is the physical impact of water resource and forest and ecosystem, human health and coastal area. And I compared each damage categories to the economic impact in figures and in tables, and to see the relative significance of each impact. So depending on our studies analysis, we find that the most damage will occur in coastal area, which is about 0.765% of GDP, followed by human health, food and ecosystem and water resource. However, as I mentioned earlier, only a limited categories are included in study. So later, more studies have done like human health, we only estimated the premature deaths caused by extreme heat. So, but there are other damages like disease and etc. So when the further research has done, this ranking or relative importance might be changed. So the next step is to see the effects of climate change policies. So we analyze the impact of adaptation and impact of mitigation policies. So for adaptation, we find that for human health sector, the adaptation policy will decrease the human health damage about 14%. And for food sector, adaptation policy not just to decrease the impact or damage, we find that the profit will increase. And mitigation is already covered by Dr. Kim, so I skip on that. And the final step is integrated analysis of the climate change. So by combining all the information I presented earlier, done by many researchers, I did the integrated analysis. I used the PAGE model. PAGE is policy analysis of greenhouse effect model. So I know the Dr. Daegisho is also used for this model for Taiwan study. And this model is already used by other studies like STONE, NRDC, and ADB studies use this model. And this is the structure of the model. So depending on socio-economic indicators like GDP and population growth and the level of mitigation policy, the GHG emission level will be determined. And then the ambient GHG concentration is calculated. Then the temperature change, and depending on the level of temperature change and how the aggressive adaptation policy is implemented, the impact will be determined, and impact analysis, and then economic valuation. So the final output of the page model is the damage and cost of each policies. And when we estimate the economic impact, we use 3 basic scenarios to reflect a very uncertain future. So we use the BAU, and the red line is low BAU and high BAU scenarios. And each BAU scenarios have different assumptions in various social and economic indicators and technological assumptions, and the effect of the use of alternative fuels. So we estimate the economic impacts for 3 scenarios, and we have 2 mitigation scenarios, depending on the timing of emission reduction. And this figure shows the damage cost of climate change in Korea for 2 scenarios. One is no action, the BAU scenarios, and the purple line is 2-degree stabilization scenario. And in both scenarios assumes the rest of the world will follow the same as Korea. So for inaction, so no country will adopt the GHG mitigation. So we assume the A1B scenario for all countries, and 2-degree stabilization scenario assumes all countries will reduce their GHG emissions to meet the 2-degree target. So in graph A shows the inaction scenario, damage cost increase gradually from 2010 to 2050. And after 2050, the damage cost increased dramatically. And for 2-degree stabilization scenario, the distinct reduction will be observed. And graph view B shows the cumulative climate change damage for 2 scenarios. The red line is the BAU scenario, the no action scenario, and the blue curve shows the 2-degree stabilization scenario. And we find in the no action scenario, there exists high probability of high cost damage. And for no action and the 2-degree stabilization scenario has low probability of a high cost damage. And we analyze the mitigation cost and benefit for no action scenario and the 2-degree stabilization scenario. Graph B shows the difference between the cost and benefit of mitigation. The blue line is the cost of mitigation, and the red line is benefit of mitigation. And the area shows the range, probability range of 20% and 80%. And we find that the benefit of mitigation occur far into the increase as far into the future. And I'd like to also say that the CO2 mitigation, the GHG mitigation, not just only have the reduction of climate change damage, but it also has other co-benefits like air pollutant emission reduction, like NOx or PM10, and it also have the energy saving benefit. And we analyze the cost and benefit of adaptation policy. So we find the adaptation policy will decrease the climate change damage about 8 trillion won, but the cost of adaptation policy is 300 trillion won. And we compare the damage and cost of timing of adaptation. So no adaptation in year 2010 adaptation, year 2030 adaptation. So in A3 scenario assumes the adaptation policy implemented year 2050. So when we find that earlier executive implementation of adaptation policy, the benefit is greater. So, and graph B shows the benefit and cost of adaptation. The green line is benefit of adaptation, and red line is cost of adaptation. So regardless of the period, the adaptation policy, the benefit always exceeds the cost. So main conclusion, major finding of study is the cumulative damage cost for Korea for the inaction scenario is about 2,800 trillion won, and the uncertainty is huge. And damage cost will be reduced globally, not just by Korea, for 2-degree stabilization scenario. And we also find that the adaptation policy will have very immediate result, and in all times benefit exceed the cost. And the growing impact of reduction, the benefit of reduction will grow and increase to further future. And however, there exist many gaps and cavities and uncertainty in this study. So major gaps is, as I mentioned several times, the impact assessment on this study is limited on a few sectors, 5 sectors. So sectors are not included in this study, including the natural disasters, which is the very high impact, and industry and infrastructures, and etc. And also the damage sector has been included, but many categories has been missing, like disease, insect in food. So further research also needed. And the benefit and cost analysis of adaptation was analysis in non-micro, in macro steps. So we need more bottom-up studies to back up this outcome. And the co-benefit included the reduced of fuel economy or impact of air pollutant reduction were considered more aggressively. The impact of mitigation, the benefit of mitigation will be much higher. So, and you also need the analyzing various scenarios, because the economic impact of climate change in Korea is not just depending on how Korea behaves, but how other countries behave. So to reflect this complex surrounding or circumstance, we need more various scenarios. Yes, that's all for today. Thank you very much for listening. Thank you.